Find the limit. The limit as t goes to infinity of t squared plus 1 divided by t times the natural log of t. If we try to evaluate these guys using the quotient rule, for instance, we'll quickly find infinity over infinity. Notice, as t gets larger, t squared is going to get larger. So t squared is going to go to infinity, plus 1 is even larger. In the denominator, both t and the natural log of t grow without bound as t gets larger. So again, we get infinity over infinity, which is an indeterminate form. So we may try to apply LHopital's rule. So by LHopital's rule, LHopital's rule says you take the limit of the derivative of the numerator, which is 2t, divided by the derivative of the denominator. Now that denominator has two factors. One is t and one is natural log of t, so we're going to have to use the product rule. The derivative of t is 1 times a copy of the second plus a copy of the first times the derivative of the second. If we simplify a little bit, we notice that we still have 2t in the numerator. In the denominator, we have the natural log of t plus, well, one of the t's will cancel, and that's all that's there, so plus 1. Once again, if we try to evaluate this, we're going to get infinity over infinity. T goes to infinity, so 2 times t goes to infinity. T goes to infinity, so the natural log of t goes to infinity, and plus 1 goes to infinity. Still, we have an indeterminate form. So let's try LHopital's rule again. LHopital's rule says take the derivative of the numerator, which is 2, divided by the derivative of the denominator, which is simply 1 over t, and then the derivative of 1, of course, is 0. 2 divided by 1 over t is the same as 2 times t. And that limit certainly is infinity. So this tells us that our original limit does not exist, and it doesn't exist because the function grows without bound to infinity as t goes to infinity.